Section 12.9 is a stationary point. First of all, let me draw a curve. Now when you look at this curve, you can see that in here the curve is increasing. How do you know the curve is increasing? If you find the gradient of this any point, you can see gradient is positive for this point. So up to here, you can see that this function or the curve is increasing. And in this point, when it's come to peak, it's it's it is neither increasing nor decreasing in this point. And then again, you can see that it is decreasing. And when it's come to this point, it is neither increasing nor decreasing again. And it is going to this point again, it is this point, neither increasing nor decreasing. And it is come to this point. Again, the same situation. It is neither increasing nor decreasing in this point. And it will go, and in this point again, it is neither increasing nor decreasing, and it is in this point again. In this point again, it is neither increasing nor decreasing. So it is neither increasing nor decreasing, it is stationary. In this point, neither increasing nor decreasing, so it is stationary, right? So in this point also neither increasing nor decreasing. So this point, in this point the curve neither increasing nor decreasing, so it is stationary. Same as this point, stationary, neither increasing nor decreasing, neither increasing nor decreasing. So if it is increasing, what do you know? Dy by dx equal to greater than 0. So up to here, up to this journey, it is dy by dx greater than 0. Then in this point, it is stationary. It means dy by dx equal 0. And again, then it is decreasing. And this is stationary. So if it is decreasing, dy by dx is less than 0. And at this point, neither increasing nor decreasing, it is 0. And again from here to here it is increasing. Again dy by dx greater than 0. And when it's come to here, again stationary. So neither increasing nor decreasing. So what is the value should be? 0. Dy by dx is 0. And again here it is decreasing. Dy by dx is less than 0. And this is again dy by dx equal to 0. Again decreasing. So dy by dx less than 0. And this point, stationary again. Dy by dx equal to 0. In here again increasing up to here function. It means dy by dx equal greater than 0. And this point again is stationary. Dy by dx equal to 0. And this is greater than 0 again. So what does dy by dx mean? The gradient. So it means it has a positive gradient here. And it is and in this point dy by dx is 0. It means gradient is 0. It means it is parallel to x-axis. And in this point it is again negative gradient. And again here what you can see, dy by dx tangent line parallel to x-axis, gradient is 0. Again it is going up positive. And here again dy by dx tangent is parallel to x-axis, gradient is 0. Then again negative gradient, again what we call dy by dx 0, negative, then again less than negative gradient, again in this point dy by dx 0 and gradient is 0, neither increasing nor decreasing, and again up to here increasing, and again in this point stationary and again increasing. Now in here you can see what is dy by dx? Positive, right? I write, okay, dy by dx greater than 0. This is dy by dx equals 0. Then dy by dx less than 0. If you see dy by dx greater than 0 and then equal to 0 and then less than 0, then what is this one called? Maximum. And if you see, right, if you consider this part now, dy by dx less than 0, this is equal to 0, and this is dy by dx greater than 0. Then what is this one? This is a minimum. So this is a minimum. So you can see this is again maximum. And now here you can see dy by dx greater less than 0, and then this is equal to 0 again, and again less than 0. It's not like this and it's not like this. That point is going to be something like this. So this is called point of inflection. Point of inflection. And you can see here also point of inflection. Positive, 0 and positive. So that is the behavior of this one. Positive, 0, positive. If it is max, what will happen? Positive, 0 and negative. It will change. Positive to positive, 0, negative, max. Right? Negative, 0, positive, mini. Then negative, 0, negative, or positive, 0, positive. So those are point of inflection. Basically, we are discussing three points. The stationary point, then before and after this stationary point, whether it is positive or negative. If you see whether left is positive and right is negative, then it is the gradient. If you see that the top gradient is 0 and the left gradient is positive and right gradient is negative, so it is a maximum. So the other way is it is a minimum. Gradient negative, 0, positive. So it is a minimum. And if you see that the gradient not a change in positive to negative or negative to positive, it is stay negative, then again negative. Negative 0, negative. Positive 0, positive. Then those points called point of inflection. Actually, this one called rising point of inflection because it is increasing. This one is falling. Falling point of inflection. Now, what is the stationary point finally? The stationary point is the point where the function neither increasing nor decreasing. Now, when you look at this curve, so this curve and is going up to here, above this point. So now we say this is a maximum. How about this one? This is also a maximum. So how about this point? That is also a maximum. So now which one is maximum? Maximum means highest point. Now, there's two words we refer. One is local. One is local. Other one is global. Local maximum means local shop. What is the meaning of local shop? The shop around you, near your house. So likewise, when you consider this area, this local area, this is maximum. Right? When you consider this local area, this is maximum around. When you consider this local area, this is a minimum. When you consider this local area, this is a point of inflection. And same as this is a minimum. This is a point of inflection. So this is a local maximum. This is also local maximum. Any local maximums? That's all. And then local minimum. Local minimum. What are the local minimum? This one and another minimum, this one. So those are the local minimums. So what are the local point of inflection? Yeah, there are two types, falling and increasing. This is local point of inflection. We usually. Then what is global? Global means there is only one. What is the maximum? It means maximum point is here. This is the global max. What is the global minimum? This is global max. What is the global minimum? Global minimum is this point. You can't find any more point in this curve below that. Global max means you can't find any more point above that. So that is the global max. So around locally you can find the small hills and valleys, right? Point of inflection. So how do you know that? How do you find the stationary point? What is the characteristics of the stationary point? Neither increasing nor decreasing. It means gradient has to be equal to 0, or it is a tangent line parallel to x-axis. That is, if you draw a tangent line parallel to x-axis. And if we have this kind of point, so you can't find the dy by dx. You can't find, right? No dy by dx in this point, because left derivative and right derivative is not equal, right? So you can't understand why it is yet. So it is you need to have a lot of kind of knowledge. So just for your knowledge, you can't find dy by dx in this kind of point, because left derivative and right derivative is not equal. This is just for your knowledge, and you can forget this one. At stationary point, the function is neither increasing nor decreasing. So when you find dy by dx, you can't find, if you see a value plus 3 or dy by d minus 245, then it is not a stationary point, because it has a value, except at a stationary point the increment is 0, or no increasing no decreasing, so it is stationary. The function is no increase no decreasing. So what are the stationary points? The stationary points are maximum, it can be local or global, minimum local or global, and point of inflection. And two type, one is falling, other one is rising. Rising. How do you determine now local maximum? Assume this is y equal fx graph, y equal fx graph. Now let's take this point x naught. Now you know that x naught is a stationary point. So dy by dx is 0. Now you want to find whether this the left side. So if you go little bit left, let's say you go left h naught distance, and you want to look at the gradient. So you want to go f dash x naught h distance to left, and you want to look at the gradient. If the gradient is positive, and we know that on this point, stationary point, f dash x naught is 0, so this is flat. and f dash x naught, so this is 0. So this is the symbol. You can see that this is positive. Mm, and then you want to just go a little bit to right, x naught, h distance to right. So and check the gradient. If it is negative, then what is this one? So this is a maximum, max. This h is very small amount. Don't go for that far. Sometimes if h is long, then you may catch to other global maximums, local maximums, right? And it will spoil. So just assume this point is 3, then you are, if this point is 3, you are going 3.01 to the right, and then 1, 3 minus 0.1, which is 2.99 to left from the number line. 3, you go and check 3.01 and 2.99. Okay. And if this is positive dy by dx, 0, and yeah, it is maximum. So same as when you go to, assume now this is the x naught, and this is y equal fx curve, and go to left, x naught minus h, go to left and check f dash x naught, and you found out this is negative now, right? So this is the shape, and we know this point is 0 now. Now this story is finished. Now this is the second story, right? First, now the second story. Then this is 0, this is flat, and when you go to right h amount, x naught plus h, then you check the gradient and it is positive, so then it's going to be a minimum. And likewise the third and the fourth case. If you see something like this, so negative, 0 and negative, you go, this is your x naught, go a little bit to left and go a little bit to right, h distance, and look at what is happening to the gradient. So then this is negative, negative, 0, negative, like this. It means point of inflection, that is fall in one. The other one, fourth scenario, this point. So you will see this is x naught. You go to left, x naught minus h, and go to right, x naught plus h, and see what is the gradient. When you go to left, gradient is positive, and you know in this point 0, and this point is negative, positive again. So this is positive, 0, positive, then again point of inflection and rising. So those are the 4 situations you can see through a graph. Let's consider a point y equal or fx y equal x square plus 6, then dy over dx is 2x plus 5. Now I get dy by dx. So what is the characteristics of the stationary point? At the stationary point, it's no the function is neither increasing nor decreasing. It means dy by dx has to be 0. First of all, find the stationary point. So then dy by dx equal 0. Then what is dy by 2x plus 5 equals 0? X equal minus 5 over 2. Now we found out the point x equal minus 5 by 2 minus 2.5. So minus 2.5. Now I want to check this is stationary point. Who knows this is a maximum or minimum or point of inflection? We don't know. Now we'll check f dash x. Let's go to a small distance to left. Can you tell me a distance? Okay, let's go. We'll take any number 2 here, minus 2. Right. Now we'll check f dash x or dy by dx. So dy by dx. This is also, you know, that f dash minus 2 or x equal minus 2, both same. We'll check the value. 2 minus 2 plus 5. This is going to be minus 4 plus 5. I think I made a small mistake. So this is 0. If you go left to minus, then it can't be minus 2. This has to be minus 3. This is minus 2 is here. Minus 3 is here. Okay. So we'll take instead of minus 2, minus 3. Now value is 2 times minus 3 is minus 6. Minus 6 plus 5 is minus 1. It means gradient is negative. How do you do a negative gradient? This is. So in here it is like this. Gradient 0. Before that it is negative. Then okay, now let's see after this point any. So we'll take the x equal minus 2, or you can take 0, but I will take a minus 2 because we can't go that far, very short. So f dash uh, minus 2 or dy by dx when x equal minus 2, both same. What is the dy by dx? This is 2 times x now minus 2 plus 5. So minus 4 plus 5 plus 1. So it is positive. It means gradient is positive. Now what you know this shape? It is a minimum. Then you will tell that. So you will explain that this is a minimum by doing this testing. Actually, you know this is a quadratic equation, right? So if this is a greater than 1, you should have a minimum. But we check this one separately. Now I put that details into a table. So this is actually x naught, this one. Then what is the h value? We go that x naught plus h. It means plus 1 minus 2 by plus 1. We go to right. And then minus 2 5 minus 1. X naught, this is x naught minus h. So minus 2.5 minus 1. We came to left. That is minus 3. and minus 3 value is minus 1. So that is negative 0 and this is positive 1. So that is positive. So the shape is negative gradient, 0 and positive gradient. You will find that gradient at minimum. Now let's discuss the second derivative test. Second derivatives test. To find minimum and maximum, but no inflection. You can only find minimum and maximum. You can't find with the inflection point through it. So what do you need to do? You take, this is the theory. Assume that when x equal a is a stationary point. Now how do you find a stationary point? Assume you have a curve x square plus 5x plus 6. Then you take dy by dx 2x plus 5, and then you want to find x stationary point. Then dy by dx make it equal to 0 because it is a station, not moving, not increasing or decreasing the function. Station 0, then 2x plus 5 is 0, x is minus 5 over 2 minus 2.5. Now you have this stationary point, x equal minus 2.5, and f dash x is, you found out, 2x plus 5 for dy by dx, right? x equal to a stationary point if then f double dash double prime, when you differentiate that function and when you substitute that value a, and you will get a positive number, then point is maximum, minimum. If you put if x, then if you put f double dash a, you found, sorry, I always use double dash, f double prime a, and if greater than 0, then it is a minimum. If double prime a less than equal to 0, then the point is maximum. If double dash a equal to 0, it is inconclusive. You can't do any decision. Then you have to go back to the previous test. Now our curve is y equal, we work out y equal x square plus 5x plus 6. Now making dy by dx equal, we found out the inflection point is x equal minus 2.5. Now we have dy by dx here. What is the instruction is given? Double prime. It means we have to differentiate one more time, d square over dx square, or f double prime. What is the value? 2. Now at which point? Minus 2. So d square by dx square when x equal minus 2.5. Or you can write this one as well. What is the value? There is no x, it's not depend on x. Then it is 2 step. If there is a x value, you have to substitute minus 2 pi, but there is no x. Right? If it is x cube, then x square, then you may get x to substitute. Unfortunately, now there is no x to substitute, so this is fixed. However, we need this value. Now this is greater than 0. Hence, what you can tell, it is greater than 0. Point is a minimum. X equal minus 2.5 is a minimum. Let's consider different sum. Y equal to x cube 15x square minus 15x square plus 24x plus 6. What is dy by now? We want to find the stationary point first. So how do you find stationary point? At the stationary point, dy dx equals 0. So find dy by dx first. 6x square minus 30x plus 24. Now I will make equal to 0. 6 square plus 30 x plus 24 equals 0. As dy by dx equals 0 at stationary point. Now I can see I can take 6 out, x square minus 5x plus 4 equals 0. Then x minus 5, x minus 4, x minus 4, x minus 1 equals 0, x equal 4 or x equal 1. Now I have two stationary point x equal 4 and x equal 1. Now I want to check this is a minimum or maximum of point inflection. This is minimum or maximum of point inflection. So what it say if x is a stationary point, if double prime. So then I have to get the second derivative d square y over dx square. Or this is also referred as f double dash. Right? Okay, first of all, we'll take this value. This is going to be 2 times 12x minus 30. I differentiate again this. Now, when x equal 4, x double dash 4, 4 di square dx square at x equal 4. So you can write either this way or this way. Now 12 times what is the x value? 4. We are checking 4 points. Now here you can see you have x. Previously you didn't have. Now this is 48 minus 30 greater than 0. If it is greater than 0, 1 point is a minimum. Point is a x equal 4 is a minimum. Now check when x equal 1 what will happen. If double dash 1 or d square y over dx square x equal 1, then 12 times what is x value? 1 minus 30. 12 minus 30, this is a negative value. Now if it is negative, if what is this one? Hence x equal 1 is a maximum. So this is greater than 0. This is minimum. So when you look at these concepts, all are, there is no, you don't need like a high level of thinking. I mean, this is just basic thing. When you learn the differentiation, what did you do here? You differentiate one more time and get to dy by dx. You make equal to what? 0. And get to the second derivative. You differentiate again. You do the same thing. Nothing else special. Then this is, you are substituting the values. This is O level, ordinary level. This is also substituting value, and according to this, you have the theory given. You give an answer. We will discuss further with the exercise.